As the world moves toward renewable energy, the challenge of storing power for extended periods remains a critical barrier. Lithium-ion batteries, while effective, are expensive and have limited lifespans. Iron-air batteries, which use abundant and inexpensive materials, are being touted as a potential game-changer. This episode explores whether these batteries can truly solve the multi-day storage problem, based on evidence from industry leaders and researchers. Can iron-air batteries overcome the limitations of current energy storage solutions and provide a viable long-term solution for renewable energy?
Form believes iron air is the best long-duration grid-scale storage solution due to its extremely low cost, safety, durability, and global scalability.
A breakthrough in iron-air battery technology raises questions about its potential for long-term energy storage. A study published in PubMed highlights the potential of all solid-state iron-air batteries enhanced by low-level K+ doping in iron oxide. These batteries can achieve 100% Coulombic efficiency and 60% energy efficiency, with stable performance over 100 cycles at 800 degrees C. If iron-air batteries can be scaled and manufactured at low cost, they could potentially replace lithium-ion systems for grid-scale storage. This could potentially reduce reliance on rare materials and improve energy security across the globe. However, this would require overcoming challenges in real-world performance and commercialization. These findings are based on laboratory conditions and may require further testing in real-world applications.
Aluminum in your entire life? Well, it works the same with iron. Oxygen reacts with iron to create iron oxide, also known as rust. And this process gives off just a little bit of energy. But before we get too far into how these batteries work,
could iron-air batteries revolutionize energy storage? Let's explore the science behind this promising technology. Iron-air batteries rely on the reaction between iron and oxygen to form iron oxide, a process similar to rusting. Research has demonstrated that iron oxides, such as mesoporous Fe2O3, can be used in battery systems with high initial Coulombic efficiency and stable cycling performance. Studies have also explored the use of iron-based perovskite oxides in aqueous batteries, enabling reversible oxygen insertion and extraction during charge and discharge cycles. If iron-air batteries can be scaled successfully, they could offer a low-cost, high-energy density alternative to lithium-ion batteries. This might lead to widespread use in renewable energy storage and electric vehicles, potentially transforming the way we power our world. However, challenges such as ensuring long-term stability and efficiency remain, requiring further research and development. While the chemistry is well understood, the practical application of iron-air batteries at scale remains unproven, and further verification is needed.
Storage. Their goal is to deliver 100 hours of continuous energy cheaper than any chemical battery on the market. And guess what? They've already
A new battery technology claims to store energy for 100 hours at a fraction of the cost of lithium-ion. But is this claim backed by evidence? Iron-air batteries use abundant and low-cost materials like iron, which could reduce manufacturing costs. However, no commercial product has yet been verified to achieve 100 hours of energy storage at a lower cost than lithium-ion. If iron-air batteries can deliver 100 hours of energy at a lower cost, they could revolutionize grid-scale energy storage. This would enable renewable energy sources like wind and solar to provide consistent power even during periods of low generation. However, this future depends on successful commercialization and independent verification of cost and performance claims. Independent cost analyses and performance benchmarks are needed to validate these claims.
Your entire life, it's rust, literally iron oxide. The same reddish-brown flaking residue that destroys cars, bridges, and garden tools.
Could iron-air batteries offer a sustainable energy solution, or are their environmental costs too high? Iron-air batteries use iron oxide, a common and inexpensive material, which suggests potential for low-cost, abundant battery production. However, the environmental impact of mining and processing iron, as well as the life cycle of the battery, must be considered. If iron-air batteries become widely adopted, they could reduce reliance on rare materials and lower production costs. However, large-scale mining and processing might lead to increased environmental degradation and resource depletion. The full life cycle assessment of the technology is not yet available, leaving many questions unanswered. While the material is abundant, the full life cycle assessment of the technology is not yet available. Iron-air batteries present a compelling case for long-duration energy storage due to their low cost, safety, and scalability. However, the technology is still in its early stages, and further independent verification is needed to confirm claims about performance and durability. If these challenges are overcome, iron-air batteries could become a cornerstone of the renewable energy transition. Until then, they remain a promising but unproven solution.